Okay, so let's talk about what you guys learned yesterday while I was gone. It sounded like it was really successful. All right, so first of all, a transversal. A transversal is something that travels through two parallel lines. So here in the picture, our transversal is the one that's going into the tree at an angle. So a transversal is a line that intersects two coplanar lines at two different points. In the figure, line T is a transversal. The table summarizes the names of angle pairs formed by a transversal. So let's talk about these angle pairs. So, corresponding. Corresponding angles are angles that lie on the same side. Now, when I'm talking about a side, I'm talking about the side of the transversal. The parallel lines go together. The transversal is the one that we're focusing on. So if I'm talking about the transversal, the same side of the transversal would be either this side of the transversal or this side of the transversal, if you're talking same side. So this definition says corresponding angles lie on the same side of the transversal and on the same side of the intersecting line. All right, so here's an intersecting line, here's an intersecting line. So 2 and 6 correspond to each other. Now, when I say correspond, I mean, isn't it like I could just, what color should I use? Blue?
Purple. Yeah. Purple, I agree.
Purple?
Purple. Purple.
Okay, purple it is. All right, so if I were to take 2, I should use pink. I think pink's a good idea. Okay, so it is like, so this one right here corresponds with this one. You see that?
Yeah.
They're like in the same spot. Hold on, hold on. We could do white. White would work too. We're going to do more, don't worry. So this one, oh, that's it right there. There's the ticket. So this one corresponds with this one. So when they say something like they're on the same side of the intersecting lines, it means they're in the same spot. So same side, same spot. Corresponding. They correspond to the same spot. Okay. That's that one. So I've got an example of that. I would write angle 2 and angle 6. Or I could write 1 and 5, or 3 and 7, or 4 and 8. Perfect. Let's talk about, so that's corresponding. Now let's talk about same side interior. Same side interior is on the same side of the transversal, just like we were talking about before, but on the inside of these lines. So the inside of these lines is all in here. See how this is the inside? And the other part out here is the outside. So if we're talking inside and on the same side of the red line, what two angles are same side interior? Angle 4 and angle 6, or I could have said angle 3 and angle 5. Same side interior. Alternate interior. So I'm still talking about that green area, right? But instead of being on the same side, they're on opposite sides. Not just opposite sides, but alternate sides. So 4 and 5 would be alternate interior, and also 3 and 6 would be alternate interior. Yes, sir?
I think.
That's what we're going to talk about next. Okay. So we've got an example, bless you, of each one of them. Now, we're going to talk about them. So this is where I'm going to redraw this. So I've got this. Let's use black. So here is one, and here's another one, and I'm going to draw a transversal that goes through them. Grab all that. We're going to label it. So I've got 1 and 2. Let's make this bigger. Take these, put them together, make it bigger. Is that going to change the size? Size of the angle? If I know that this is a 90-degree angle, let's see, let me give myself a box. If I know that that's a square, and it's 90-degree angles, isn't it still 90 degrees? Does that make it bigger and smaller?
Yes.
Okay, so just because I made it bigger isn't going to change the angles. It's just blown up a little bit. Okay? All right. So this is going to be angle 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. Now, without actually measuring these angles, because of time, because you should have done that yesterday, right? Did you measure them?
Yes.
What was angle 1? 135?
45.
I like 140 better. Why do I like 140 better? Because it's nice and even. What was angle? 5. Angle 6. It doesn't matter. Angle 7. Angle 8. So angle 2 was 40. Angle 3 was? Let me look. 2 and 3. 2 and 3 are what type of angles? They are vertical. Therefore, it has to be 40. Angle 4, angle 4, and angle 1. Angle 4 and angle 1 are also vertical. Therefore, they're congruent. Angle 5. Angle 5, I'm guessing, is going to be the same as angle because they are corresponding. When you correspond to the same spot, you also correspond to the same size of that spot, right? So that's going to be 140. Got angle 6. What do you want to compare angle 6 to? Angle 2? Okay. Angle 2. I could also compare it to angle 3. If I'm talking about 3 and 6, what are those? They're on the inside, so they're interior. Are they same side interior or are they alternate interior? They're alternate interior. So if I know 3, I know 6. 40. Angle 7. It's vertical. It's also corresponding, right? Okay. So it's what? How much? 40. And 8? 140 because it's vertical. It's also corresponding with 4, right? All right, so what can we say about corresponding angles? They're congruent. Why is this so messy? Let me just write with this one. So they're congruent. What can I say about alternate interior? Alternate interior. Alternate interior. What do I know about 4 and 5 and 3 and 6? Here's 4 and 5. They're congruent. We'll just copy that one. I like that one better. It's smaller. They're both congruent. What about same side interior? Here's same side interior, 4 and 6. I'm going to highlight it with green. Here's same side interior. Here's same side interior. What do we know about same side interior? What? They're supplementary. Because look, doesn't 4 and 6 add up to 180? So they are supplementary. Just makes it too big. Now it's pretty. Okay, so questions before we move on. So we have 3 types of angles. Same what? Same side interior. Alternate interior. And corresponding. That's the new ones we learned. What's the other one that we know that's also involved in the picture? Well, the supplementary angles are in the picture, you're right. We're talking about if I were to name angles. Somebody already said it. What other type we're talking about in here? What are 7 and 6? Vertical. Good. All right. Let's use this. So on page 176 in your textbook, let's talk about transversals and parallel lines. So get that out, please. Okay. So when parallel lines are cut by a transversal, the angle pairs formed are either congruent or supplementary. What are the types of angle pairs again? Let's name them out again, guys. Okay. Vertical, alternate interior, same side interior, corresponding. Okay. So all of those angles are one of 2 things. They're either congruent or they are supplementary. So let's talk about this. Discuss and be ready to share. Explain how you can find the measure of angle 3. So here's the measure of angle 3. If the diagram has P parallel to Q, and the measure of angle 6 equals 61. So discuss that for a brief moment. All right, Kara, go ahead and share. Fantastic. So she said that 3 and 6 are supplementary angles. How do we know they're supplementary? What do we call these angles? Same side interior. So since they're same side interior, we know they are supplementary. If they're supplementary, the measure of angle 3 plus the measure of angle 6 equal what? 180. Well, I know the measure of angle 6. The measure of angle 6 is 61. So how would I find measure of angle 3? How do I find this? How do I find measure of angle 3?
180 minus.
Subtract. Just subtract. So 180 minus 61. Did anybody do it? 119. 119, that sounds right. Degrees, degrees, degrees. Precision, right? We're talking precision. If I don't have numbers, I have degrees. Okay. If line M is parallel to line N, so now we're talking this picture down here. A little different. M and N are parallel. Correct? they have a transversal. It's right here. So different than this one. The transversal here is vertical. The transversal here is horizontal. So when we're talking same side, we're talking either the top of the red transversal or the bottom, right? If I'm talking interior, where would interior be? Inside the two parallel lines. Kind of stretch it a little bit here without distorting the picture. Okay, so how many pairs of same side interior angles are shown in this figure? How many different than here are the same? Say it louder, Heaven. 3 and what? 3 and 4. Are 3 and 4 same side interior?
No.
They're not alternate. Alternate would be 3 and 6. Which ones would be same side? Okay, 7 saying 3 and 5. What do you guys think? Thumbs up or thumbs down? Thumbs up or thumbs down? I want to see it. Let's see it. Good. General consensus says 3 and 5 are same side. Can somebody give me another angle pair that's same side? Tyler? 4 and 6 are also same side interior angles. So we have 2 pairs. Okay, if 3 and 4 aren't same side interior angles, what would we call 3 and 4? I'll give you a clue. They are supplementary, but the reason we know they're supplementary is not one of the angle theorems that I just gave you. That's it. They're a linear pair. Good job, Giovanni. Giovanni, can you explain to me how you know they're a linear pair? They form a line. If I were to take a little picture, guys, do you see it? Pink. So if I take this angle, grab it, put it over here, and make another angle for 4, grab it, put it over, that didn't work, and grab it and put it over here, together they form a line. Yes, they do. Look at that. So 3 and 4 are a linear, oops, it's like a B. 3 and 4 are a linear pair. Since they're a linear pair, we can say that they are supplementary. Since they're supplementary, we can say their measures add up to 180 degrees. Excellent. Let's move on, guys. All right, let's do a proof. Pencils down, pay attention. All right, so prove the alternate interior angle theorem. If I need to prove alternate interior angles, I can't use the fact that alternate interior angles are, what are alternate interior angles again? Congruent or supplementary? Okay, we gotta do this again. We have alternate interior. We have corresponding and same side interior. I had somebody say in the other class that alternate sounds to them like the same thing as vertical, like the opposite side. So alternate would be, just like 4 and 2 are vertical, 4 and 6 are alternate. See how one's on this, one's up, one's down, alternate. One's up, one's down. Just like one's up, one's down, that's how he remembered it. So just like vertical angles are congruent, alternate interior angles are also what? Congruent. Corresponding angles would be like 2 and 6. They're in the same spot. If they're in the same spot, are they congruent or supplementary? Congruent. Why are they congruent? Not just because they're corresponding. They're angles. Look at, they're in the same spot. If they're in the same spot, they share the same angle, right? Same spot, same angle. Same side interior is the only one that's different. They're in the same side, just like a linear pair makes up a line. Aren't the 3 and the 6? If you took the angles and like tweaked them, turned them around, they would also make a line. They don't make a line right now, but if you were to manipulate them, like, I wonder if I can do this with tools. Let's check it out and see. Here's 3. Grab that one. And here's 6. What do you think I'd have to do? Put it on top? Like that. If I put it on top and pretend like it's over here, that's interesting. Check this out. Isn't 6 and 2 corresponding? Same spot? So I could take it, put it in the same spot, and now it becomes a linear pair. Do you see that? Here's 6. Put it in the same spot where 2 is, and 2 and 3 are a linear pair. See how it's all connecting? Yes?
Yeah.
7? Connection? Okay. So we say that same side interior are supplementary. All right, so let's use all of this. So let's get back to our proof. Alternate interior angles. I'm going to try and prove that they're congruent or that their measures are equal. I can use corresponding. I can use same side. I can use vertical. I can use linear pair. I can use supplementary. I can use everything. What can I not use? If I'm proving alternate interior, what can I not use? Alternate interior. I can't use alternate interior if I'm trying to prove alternate interior. It doesn't make any sense. It's like saying, why? Because I said so. Right? Because why not? That's what you're doing when you do that. Because I said it. Why are alternate interiors congruent? Because I said they were. Can't do that. Okay, so let's use this. So we already got the proof already laid out for us nicely. So now we just have to justify our statement. Okay, so the first one is, first of all, we should probably grab what we're trying to prove. I'm just going to grab this right here. Grab this, cut it, and paste it. But right here so you can see it. Sound good? Yes, Mrs. Mahler, it sounds fantastic. Okay. Okay, so first it says P is parallel to Q. We were given that. That one's easy. Awesome. 3 and 6 are supplementary. Let's go look at where 3 and 6 are. Here's 3. Here's 6. What type of angles are 3 and 6? They are same side interior. Same side interior angles are supplementary. So what justification can I give for saying that 3 and 6 are supplementary? Same side interior postulate. Excellent. Okay, so now I always keep going. I go back and I say, okay, so if these are parallel, then I know 3 and 6 are supplementary. Therefore, the measure of 3 and 6 equals 180 degrees. How do I know? Definition of a supplementary angle. Good. You see how it flows? Supplementary, 180, how do I know? Because that's what supplementary means, 180. All right, this is where it kind of gets tricky a little bit. And if you took geometry last year, your teachers probably didn't do it like this. Angle 5 and 6 are a linear pair. Let me go look and see what angle 5 and 6, where it is. Here's 5 and 6. How do I know 5 and 6 are a linear pair? But it doesn't tell me anything about the measures of the angles being 180. It just says it's on a line. How do you know it's on a line? How do you know it's on a line? Because it's on a line. It's in the picture. Did they give me the picture? So what's my reason? They gave me the picture, so it is given. There we go. It's given. Okay. So since now we're going in that direction, right, Alex? So since I know that they're a linear pair, I can say they are supplementary. What tells me they're supplementary just because they're a linear pair? Linear pair theorem. Good, guys. You guys are getting this, huh? So they're a linear pair, therefore they're supplementary, therefore they add up to 180. Alex? Definition of supplementary angle.
But for the number 4 thing, the definition of linear pair?
No. Yes. You could use definition of linear pair. That would work. I don't want to do that with these guys because definition of linear pair and linear pair theorem, I have a feeling that they're going to mix those two up. Okay? But yes, you can. Alrighty. So measure of angle 3 plus measure of angle 6 equals measure of angle 5 plus measure of angle 6. Where are they getting that from? Joe, can you tell me where they're getting that from? No, not the picture. 3 and 6. Where do we see 3 and 6 in the previous steps? Because everything I get has to come from something before it. Step. That's exactly what I wanted to hear. Say it again, Joe, louder.
From step 3.
From step 3. Step 3 says measure of 3 and measure of 6. Where do we get the other part, 5 and 6? Step 6 says 5 and 6. So how can I make this connection right here? If this one is 180 and this one is 180, then they're equal to each other. Because 180 equals 180, therefore this must equal this, right?
Yeah.
Fantastic. So that would be substitution. Now, how do I get from this, where I've got 3 and 6 and 5 and 6, to only 3 and 5? You guys are so smart. I subtracted. Good. All right, we'll keep doing this over and over again. Our activity on Friday is I'm going to give you all the statements and all the reasons, but I'm going to mix them up, and we're going to cut them up, and we're going to paste them in the right order. Sound good? Okay. All right, I don't really necessarily need you at 10 more minutes. I don't really, and since I had to go over what the sub went over, or what you guys went over, instead of discussing, let's just go through this pretty quickly. So in the figure, explain why 1, 3, 5, and 7. Let's see. 1, 3, 5, and 7 all have the same measure. I heard one thing. I heard corresponding. They're vertical angles. I like the vertical angles. They're also corresponding. They're 3 and 7 correspond, 1 and 3 are vertical. So you're both right. Okay? Do they make a linear pair? No. They don't make a linear pair. They don't make a linear pair because they are the same, right? When would they make a linear pair? But let's say they are 3 and 7. No, I can't even go there. I'm not even going to. Okay. Proving the corresponding angles are congruent. I'm not going to go through this proof today because I would rather go to this problem here. So go to B in your book right here. This one, it's a good problem. It's just the picture is a little bit tricky, so I'd like to go over it with you, and this will help you with your homework tonight. This picture is just awful. They do look like streets. Why would they use streets to talk about parallel lines in a transversal? Because it's a real-life application. You have streets all over the place that are parallel to each other and have transversals. What's two streets here in Upland that are parallel to each other? Euclid and Mountain. What's the transversal between Euclid and Mountain?
Any horizontal street.
Any streets of east and west, right? What if I said, no, 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 I say that baseline and foothill are parallel. Am I right? What would be the transversal of baseline and foothill? Any vertical or north and south street, right? Where's the 16?
Baseline and Montclair and...
Oh, I know which one it is. Okay.
Yeah. Okay. Okay, back up here, guys. All right, so in the diagram, roads A and B are parallel. So I'm going to draw that. What was I using, blue for parallel or black? Black. So this is parallel. I need the talking to stop, guys, until I ask you. So these are parallel, and this is my transversal. Okay? Okay. So find the measure of WUV. Sounds like a radio station. WUV is right here. That's what I'm trying to find. All righty. So it says it is given that the measure of PRS, there's no P here, but this is it. This is PRS. PRS is 9x. And the measure of WUV, that's the one they gave us, is 22x plus 25. PRS and RUW are equal. Where's RUW? RUW, right here. RUW. How do I know their measures are the same? How do I know this one and this one are the same? Excellent, I heard it. Corresponding angles theorem. They're in the same spot. They correspond to the same spot. They're corresponding angles. RUW, which is here again, RUW, and what are supplementary angles? WUV. Correct? So angle WUV and RUW. So this one, and we'll change our color. And this one are supplementary angles. Okay. So the measures of them equal 180 degrees. Solving for x. Okay. How do I know what the measure of this one is? It doesn't tell me. It's the same as 9x because they are congruent corresponding angles. So this one is also 9x. So how am I going to use the fact that I've got 9x and 2x plus 25 to figure out x? How would I do that? Add them up because they will equal 180. I don't really like how the book does it right here, where it just jumps to this step. So now I know I have 31x plus 25 equals 187. And x equals, you may do the math? Five, good. All right, it equals 5. Substitute the value of x to find what would this be? What do they want here in this blank? The answer. Okay, we know we're trying to find the angle. Okay, so when we substitute, we get what? What's 22? What's 20 times 5? 100. Plus 2 more 5? 110. Good. What's 110 plus 25? 135. 135? No. Degrees. Thank you. Fantastic. Question. Do you see how you use clues to find? Yes, ma'am. Sure. Yeah. You can use patty paper. Okay, I still need your attention, please. 5, 4, 3, 2, 1. We're not done. I want your attention, full attention. We're not leaving until we're done. So everybody needs to stop shuffling, please. Here's your closing thought. Don't do it until we talk about it. How is the same side interior angles postulate different from the other two theorems we talked about? Alternate interior and corresponding. How is same side interior different from alternate interior and corresponding? Yes. Okay, so we've got alternate, same side interior, and then that's in one group that they're talking, and then we have alternate interior and corresponding. So what I'm hearing you say is that this is on the same side, this is on opposite sides. But look at, when we put the corresponding with it, that reasoning doesn't work, because corresponding is on the same side too. So how are same side interior, this is one subgroup, and alternate interior and corresponding different? Let's hear it, Chris.
Same side interior, they add up to 180.
Fantastic. So these would be supplementary. And these two would be congruent. Good. That's what you want to write. That's what this lesson was about today. This is supplementary. These two are congruent. What else can I add to the list that's congruent? I heard it. What? Vertical. Good, guys. Vertical angles are also congruent. What else is supplementary? I heard it. Good job. Linear pairs. Putting it all together, yeah? Because same side interior are just linear pairs that are moved inside, right? Fantastic, guys. Good job.